So I'm going to do another example of a dihybrid cross, and that's what the 4x4 Punnett squares are called. It's the dihybrid cross. Except this time I'm going to cross two different traits. It's going to be the same F1s, both hybrids, both expressing dominance. So I have two parents, both expressing dominance. T's for being tall, P's for being purple. Again, these are traits for Mendel's P's. Being tall is dominant to being short, so capital T is tall, lowercase t is short, and purple is being dominant to being white, so capital P is for purple and little p is for white. So I'm crossing a pair of F1 hybrid parents, heterozygous parents. Both parents are tall and purple, but they're hybrid for the trait. So before I cross, I need to write on the top here the possibilities of one of the parents. So I'm going to choose the first one, and he's going to be on top. It doesn't really matter where they go, but I just arbitrarily chose this as such. So the possible combinations are, and you have to include both traits at the top of each box. So big T, little p, big T, little p, big T, big P, big T, little p, little t, big P, and little t, little p. So those are the possible combinations for the green parent. They're both the same, but I just colored one green. And the combination for the second parent, I'm going to put them on the side, are the same because they're identical. Big T, big P, big T, little p, little t, big P, and little t, little p. And now you're going to go ahead and do your wonderful crosses. So what I'm going to do is I'm going to first put one copy for each from one parent, and then I'll fill in the other one. So here, each square will have a big T, big P from this one. Each square from here will have a big T, little p from the other parent. So I'm filling in one pair at a time. You can do each square at a time. I'm just doing this because, well, that way I don't have to switch colors every time to save some time. Hey, I made it funny. Because every time you cross, you'll have one of this and one of this. So I just filled in the left parent first, and I'm going to fill in the other parent. So unfortunately, you have to be careful here because it is possible to make a mistake. You know, you write a big T where you're supposed to write a small t, right, like right there. It's a little t, big P. So yes, mistakes are very easy to make. Let me correct that real quick. Okay, continuing on. This is why I don't like this method, because it's not too difficult to make a mistake. Alright, filled out. So now that the dihybrid cross, or the 4x4 Punnett square, is complete, you can easily pull off traits and figure out their ratio. Well, not easily, but you can. For example, if you want to see the ratio of two capital T's and two capital P's, well, that's the only one in the entire cross. I mean, you have to really look at them. I just know there's only one of these, so that's 1 out of 16. If you want to look at ones that are big T, big P, or sorry, little t, big P, little t, so hybrids, you can find them. Let's see, where are they? Well, that's 1. So that's big T, little p, big T, little p. There should be one more like that somewhere in here. No, 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 no. Anyways, if I did this correctly, you would be able to figure out the ratios of all the combinations just by looking at it and then counting the number that you find over 16, and that would be a ratio. But setting this up is difficult. You can make mistakes, and actually finding all the corresponding traits, sometimes it's hard as well because they're not that easy to see. So instead, there's a shortcut method of doing this, which I'm going to show you now. I showed you this in class. So I'm going to remove this. So if you were not sure how I did the dihybrid cross, you can just go back and look at it. But this is gone, and this takes its place. So again, I'm crossing the same two parents. I'm not doing anything different when it comes to the cross. But instead of crossing them all at the same time and creating this giant dihybrid cross, I'm going to cross them individually for traits. So what I'm going to do is I'm going to cross tall first, all alone. So yeah, tall versus short, all alone. Then purple versus white, all alone, and they're individual 2x2 squares. And then I am going to multiply the two ratios together to get their actual ratio as a combo trait. So here's how that works out. So starting with the first one is tall versus short. So tall versus short, I'm just going to fill that out. So tall, tall, short, short versus tall, tall, short, short. So there we go, homozygous dominant, homozygous recessive, and a pair of hybrids. And these are obviously the same, but letters are switched. I'm going to do the same thing for here. And so big P, little p, big P, little p. Hopefully they're different enough. So big P, little p, little p, big P, little p, little p. So again, your dominant, homozygous recessive, and your pair of hybrids. Again, you can move the two letters around. So these two are technically, or not technically, they're the same. All right, so now let's look at all of our possibilities of combinations from each one. So let's look at short versus tall first. So you can have two big T's. You can have big T, little t, and you can have little t, little t. 1 out of 4 chance of getting two big T's. 1 out of 2 because it's 2 out of 4 of getting a hybrid, and then 1 out of 4 to get that magical homozygous recessive. And then over here I'll do the second cross next to it. Big P, same thing, 1 out of 4. Big P, little p, it's 1 over 2. And then little p, it's 1 over 4. Now, next part is whatever the desired trait combination is, you just multiply the two together and you get your answer. So with the combo, I'm just going to use black for both, just so I don't have to switch pens every time. So let's say I want the first possibility, big T, big P, big P. So I'm crossing these two together. I got to multiply their fractions. 1/4 times 1/4 is 1 over 16. Let's say I want big T, big P, little p. I want to get this and this together. Multiply their fractions. 1/4 times 1/2. That's 1 over 8. Let's say I want big T, big T with little p. Multiply their fractions, 1/4 together, and you get 1/16. Next, you go down the line. Let's say you want this and this crossed. I'm going to run out of space. So big T, little p, sorry, big T, little t, big P. So 1/2 times 1/4. And that is 1/8. Then you want to, let's say, cross our hybrids together. Big T, big P, little p. And that's 1/2 times 1/2. And that gives us 1/4. And then moving on, and I am going to run out of space. Oh well. I want to cross big T with little p. That's 1/2 times 1/4, which is 1/8. Need a new piece of paper. Next up, I want to cross little t with big P. So this with this. So it's 1/4 times 1/4, which equals 1/16. Then I want to cross little t with big P, 1/4 times 1/2, 1/8. And then little t with little p, our homozygous recessives for both traits. That's 1/4 times 1/4, 1/16. So instead of going into the original dihybrid cross and trying to figure out, well, let's look at 2 little t's and 2 little p's, which was right here, and it's once, and you have to make sure it's only once out of the 16, so it's 1/16. Here, mathematically, you're 100% sure that it's 1/16, and you got the ratios for all of the combinations. So all the combinations that were present here are now present here, and now with just pure math you can figure out all your proportions. Which way is better? That's going to be up to you. If you are very careful and you like drawing the dihybrid cross, perfectly viable, and you're more than welcome to use it. If you like the math way better, go with that one. There really is no correct or incorrect way. Now, remember when in the notes when we did the dihybrid cross, they told you that it was 9:3 to 3:1 ratio. Now that's the phenotypic ratio, which means that you have 9. So let me talk about that as well. Actually, I'll make a separate video and I'll post that video as well. So that's it for the dihybrid cross, and I'll put up another video that talks about what that ratio means.